the way to do this is to have a crew tended by androids, who have no expiration date. If they can self-repair, self-maintain, and recharge, they can last for centuries. And you will be traveling in the form of your DNA.
Mm.
So my DNA would be on board, and some recordings of my thoughts and history would be on board as well. And then I get replicated once I get there.
Hello, everyone. This is the Space Café Podcast, and I'm Marcus. So we are living in the moment when space flight starts to feel ordinary, right? The heroic age gradually, or maybe even rapidly fading. And that's, in my opinion, when things are getting truly interesting. My guest today is Dr. Pascal Lee, a planetary scientist, Arctic field explorer, and one of the sharpest minds thinking about how we actually live off Earth. We talk about the real space race, not who touches the moon next, but who builds the very first permanent base, and why the South Pole might be a scientific treasure, yet a terrible place to live, and why a name from science fiction could become our first lunar address, and maybe the address you should redirect your Amazon delivery to, and that would be Clavius Crater. Then we push even further Android explorers, and this is when things, get really, really interesting. AI as teammates. The idea that machines carrying our DNA might cross the stars and restart the human story elsewhere. If a machine walks on Mars and thinks like us, is it still us? From lunar logistics, my friends, to the philosophy of identity, this one lingers. So, without further ado, this is Dr. Pascal Lee in the Space Café Podcast studio. Let's go.
Well, a lot has been happening in space. I think what this epoch will be remembered for is when access to space all of a sudden really accelerated and became a lot more democratic, in the sense of more people who were not professional astronauts starting to travel to space. It's a bit like, the early days of aviation, when more and more people were flying. If you start losing track of who's in space and what their names are, you're entering, you're out of the heroic era in some sense.
Where do you see
And
us? Where do you see us now? Like if you compare that to, I don't know, the advent of cars or aviation, where do you see us now?
I see us in the, pre-World War One, in the 1905, 19, somewhere in there. Yeah, where there's more and more
Wow.
people flying. Yeah.
Mm. Hmm.
And, but eventually, um, but it's still an extraordinary thing. It's still an extraordinary thing. And of course, there's some destinations we haven't reached, so the people to return to the moon will go down in the history books. And then the people who go to Mars will probably be in the history books as well. But then, we'll
Well,
eventually
well,
lose track, and yeah, more and
well,
more people will go.
that's a good point that you're mentioning. Will people who are returning to the moon now really go down in history books, or is going back to the moon, is that almost becoming a necessity and not such a big thing anymore
Well, I think
compared to
it's
Mars? Compared to Mars.
yeah, I think returning to the moon is a necessity, in the sense that it's become an arena of not just exploration, but it's an arena of strategic interest.
Mm.
So, just like going to Antarctica in the polar regions, for many nations, it became a strategic thing. You have to be there
Mm.
to be part of the players, so to speak. And I think it's the same thing with the moon. Right now there are two contending space powers who can reach the moon with people, and that's China and the
Mm.
United States. And I think the United States somehow got itself into this awkward and unnecessary space race against China to return to the moon, when in fact we shouldn't even be worrying about that. I mean, the United
Mm,
States reached the moon 60 years ago,
mm,
been there, done that. So, who returns to the moon next, in my view, is not important as
mm.
much as who's going to be setting up the first base.
Yes.
Setting up a base on the moon, which is a permanent human presence, is really the new thing that I think is the real space race that we face with with other nations like China and their
This, I
allies.
mean, like in the public eye, at least as far as I'm concerned, I do not sense a space race. I sense a very strong China, where it's not really clear what they're up to. I know the South Pole is of interest, etc., but I do not see that kind of space race we know from back in the day between Russia and the United States. So is this somewhat comparable, or is something going on in the background that I'm not aware of?
I think your characterization, as far as the public's perception, is correct. There doesn't seem to be the grounds for a space race, but from the standpoint of people who are interested in the national interest, for example, of the United States, or Congress, who is looking after our position in technology in general, there's definitely a space race in the sense that there's a big concern about China's very rapid and successful progress in space, not just in human spaceflight, but also in space robotics and in robotics in general. So there is definitely a more than a perceived space race. There's something that is being called a space race here in the U.S., which I think once again is a bit misguided by saying that we're racing to return to the moon. It's not really that. That's not really the race, in my view, that we should be concerned about. We meaning the U.S. The race that we should be concerned about is who's going to set up the first base. And I've been advocating that the United States not do what it's currently doing with the Artemis program, which is to land at a different location each time, do a bit of an Apollo repeat, except that now it's at the South Pole. But instead, send robotic missions mostly to the South Pole, which is very difficult and challenging to explore. And meanwhile, they should have humans focus on building a base immediately on the moon elsewhere, not at the South Pole. But I have my favorite spot, which is Clavius Crater. We can talk about that uh, if you want.
If, Before we do so, why is the South Pole of interest?
Well, the South Pole is of interest because at the South Pole, we have detected, and at the North Pole as well, but more so at the South Pole than at the North Pole, we've detected water ice. And water ice is a bit of a surprise on the moon because most of the moon is very dry and has no water whatsoever to speak of, except some very minor amounts. Um, but at the South Pole, there are concentrations of water, and it is in the form of ice. Technically, what we are detecting are concentrations of hydrogen, but the hydrogen is not there as free hydrogen. It's there most likely in the form of water. And it makes sense because the South Pole and the North Pole are places where there are places that are permanently shadowed. They never see the disk of the sun. In particular, the deep insides of big craters at the South Pole, sunlight will light up the top of the crater, just the rim, given the angle of the sun at the South Pole, but not the inside of the crater ever. So inside of
Wow.
these impact craters at the South Pole, you have temperatures of order 50 Kelvin, which is,
Wow.
minus 220 degrees or so
Wow.
Celsius. That's the temperature
Wow.
at the surface of Pluto. And so in this extremely cold environment, it's actually possible for water, if it was on the moon, and it seems like it is, to get trapped and to accumulate. So the big attraction, and this is sort of the strategic decision that was made to target the South Pole, is to say, wow, there's water there. That's a big resource. If we can find water on the moon, then we don't have to bring it from the Earth. And with water, you can, of course, you have to melt it to drink it, but you can also break it down, H2O, into hydrogen and oxygen.
Like fuel.
That's rocket fuel.
Mm.
And so now you don't have to travel to the moon with the fuel to come back. You can go to the moon with, smaller rockets and more cheap ways. You refuel on the moon and then you fly back to the Earth. That makes it
And
a lot cheaper.
we learned in a couple of episodes ago, we learned even that combined with a bacteria from Finland or from the marshes of Finland or Sweden, you could even create or produce protein from water. Water plus bacteria creates protein. So, I mean, like water, what takes care of
Yeah,
everything.
water is a very important resource. However, where I think is a big strategic mistake now is to jump to the conclusion that just because there's water, that there's actually enough water to make it economically viable to extract. And so often you will hear that, well, in the South Polar region of the moon, there's the equivalent of 200,000 Olympic-sized swimming pools worth of water. Okay, well, that sounds like a substantial amount of water. But in the end, it isn't, because we have maps now of where the hydrogen is most concentrated and therefore where the water is most concentrated in the South Pole of the moon, at least within the top 1 meter of the soil.
Mm.
The hydrogen detection doesn't go below. And in the places where there is the maximum amount of hydrogen detected, it's still only 0.5 weight percent. So what that means is if you excavate a metric ton of lunar soil, you can extract 5 kilos, 5 liters, therefore, of water.
Mm.
Okay. If you are 100%
Wow.
efficient. Okay.
Wow.
Now, talking about using that water to break it down into hydrogen and oxygen to refuel a rocket like Starship, a single Starship to get refuel requires 1,000 metric tons of water.
Wow. Okay.
So to achieve a single refueling of the Starship, you have to excavate what amounts to 26 American football fields down to a depth of 1 meter and be
Wow.
100% efficient at recovering the water ice there, which is, of course, very difficult to do because as soon as
Wow.
you expose it,
Mm.
you're going to lose some of it to vapor. Um, and and even if, I mean, that right there tells you that it's completely possible that all the ice at the South Pole of the moon will just remain a scientific curiosity, but not something that's economic to extract. But the other thing is, to extract water from the moon, it's not just a matter of excavating it and exposing it. I mean, first of all, that alone could be very difficult to do because you need to operate at temperatures that are extremely cold. I mean, digging into soil that is frozen at 50 degrees Kelvin at Pluto's surface temperature, you don't go there with a shovel, okay, or even
Yeah.
a
It's
terrestrial
like concrete.
excavator. And terrestrial excavators require gravity to sort of dig in. If you try to excavate something like that, you just lift your vehicle in the lunar gravity. You see what I mean? You're very light. So anyway, that's just excavating. But then you have to confine the water so that it doesn't escape into
Mm.
go from ice to vapor and disappear in space.
Mm.
Then you have to liquefy it, or at least separate the water from the dirt. Then you have to presumably transport the water. To transport the water, if you know how much heat it takes to melt ice, imagine how much energy it takes to melt ice that's at 50 degrees Kelvin to bring it to becoming liquid so that you can transport it. And I mean, transporting it by steam is even worse because now you have to heat it to the point where it's steam as well. So my point about all this is not to say that it's not possible, and that's always a very dangerous thing to say. It's not possible. The point is, will it ever be economically viable to extract water from the moon? Because what's the alternative? The alternative is to bring the water from the Earth, and a single landing of a large Starship can land 125 metric tons of water on the moon, anywhere you want. It's clean, purified water from the Austrian Alps or the French Alps or Fiji.
Mm.
Okay. You can have 125 metric tons of Avion water landing on the moon with a tap
Liquid
at the
death.
bottom. Okay. And right there, when will you have 125 metric tons of lunar water sitting on the moon in a
Mm.
place where you want it
Mm.
for you to use? And of course,
Mm.
you might think flying water from the Earth is not economically viable. Well, I mean, first of all, we do that even on Earth. In America, for
Yeah.
example, you can buy water from the French Alps
Mm. Mm.
or the Austrian Alps. You can buy water from Fiji. So we even on Earth transport water, even though it's a crazy idea when you think about it. Why not just use our own water? Okay, because we can. And the other thing is, you can recycle the water that you bring to the moon. And recycling water is something that's done on the International Space Station, for example, already now. Astronauts drink recycled urine and sweat every day on board the space station. So, with 125 metric tons of water brought to the moon by a single Starship landing, you can
And last quite
support
a while.
quite a
Mm.
while. Yes,
Mm.
and of course, what this means is that the biggest source of water on the moon is simply the Earth. All right. So this whole strategic rush to go to the South Pole, especially with people, is really, in my view, misguided, because even though there are still some unanswered questions about the concentration of water, maybe there are places where there are pockets that are much more concentrated of ice that we just can't see from orbit. Maybe there's a lot more at deeper depth. It doesn't necessarily make it more easy to extract, but it might be somehow economically worth it down the road. It's still completely premature to send humans to that region, which is otherwise very difficult to explore.
May I
The lunar
just
south.
ask? May I
Yeah.
just ask very briefly how big is that region compared to, I don't know, places on Earth? Because I'm just wondering, they who set up shop first, could they make any claims, like territorial claims, on the moon, on the South Pole, because the region is a small place? I don't know.
Right now, the Outer Space Treaty works this way. If you have any assets positioned on the moon, there's automatically a perimeter around those assets where people are not supposed to disturb it. So effectively, you claim that area. It's a local area. It's not very well defined. It depends on what you have. But, like the Apollo landing sites, for example, everybody agrees that they should not be disturbed. I mean, they have historical value, of course, but even if they didn't, they're somebody else's stuff. And so you are supposed to stay away. All right. Define away. Well, it's
Mm.
understood to be, a few kilometers would be considered away when you don't essentially affect other people's stuff. But that can
Mm.
be done with robotic assets. The Outer Space Treaty doesn't say that you have to be there with people. So if we really wanted to claim the South Pole itself or some particular spot, you just send a robot there. And now all of a sudden you have a perimeter around it that is considered to be not to be disturbed. And so China is planning to send its Chang'e 7, its next mission to the moon, to the South Pole. And everybody can tell is that they're going to try to land at the very South Pole, even though the actual South Pole is not that interesting. as a place to find water. It's a strategic spot, as you mentioned, just because it's the South Pole. All right, and symbolically, of course, it's an important place to occupy.
How big is the
Uh,
place?
But the South Pole region that we're talking about is a circular region that would fit roughly inside Antarctica. So it's, a few hundred, several hundred kilometers across. If you, depending on how you define the South Polar region, it could be, up to 1,000 or so kilometers in diameter. But it's that's the South Polar region, and it's the places where you have the largest abundance of permanently shadowed regions, and therefore places that seem to be repositories of water. Now, interestingly, the water
Would
ice
we
is not only
once
in the shadow.
if we wanted to set up shop like with permanent lunar bases, would we go into those shadowed places
No, so
rather?
precisely not. Precisely not. Not only do you not want to set up a base in the permanently shadowed regions for the obvious reason that they're super cold and you'd be in complete darkness at all times. The terrain at the South Pole in general is very, very rough, mountainous essentially. And not only that, but the shadowing changes all the time, relatively quickly. So one moment here you are in daylight, and then a few hours later or a few days later you are in darkness for several days sometimes, and then you are back in daylight a little bit, and then you're in darkness for weeks sometimes. And so even if you're not permanently shadowed, there's a huge amount of shadowing going on at the South Pole, which means that imagine you're planning a drive, a rover traverse to go collect samples away from your base. I mean, you'd be driving mostly at nighttime, so to speak, if you wanted to do that, which is possible. I mean, we can use LiDAR and, various navigational tools, but it's a complexity and challenge that is really unnecessary at this stage of lunar exploration, especially because the main reason why we would be sending humans there to set up a base there is if we could extract water. And until we have a better understanding of how much water there actually is and whether or not it will ever be economically viable to extract, it's a huge strategic gamble to go back to the moon and face such challenges in the exploration of the South Polar region
Mm.
without there being a real promise of being able to extract water.
When you talk about water, are we talking about H2O water as
Yes.
we know it on Earth? Would it be potable?
Well, if it's extracted and separated from the dirt, yes,
Mm.
it would be potable. I mean, it can be purified. It can be the chemical processes to do that. But again, it goes back to the amount. We're talking about machines that would have to operate at Pluto temperatures. We don't have any of those cryo robotics.
Mm.
Robots that work in extreme cold. That, as you know, an engineer doesn't like cold.
Mm.
It's bad for batteries. It's bad for mechanisms. It's bad for grease. It's bad for all kinds of
Hmm.
reasons.
Hmm.
And so it's bad for electronics.
Hmm.
Um, so you know, the I think, and the problem really is that people who are claiming or thinking about setting up a base at the South Pole, the real driver for that is because they imagine the base to be a mining operation. And setting up a mine, let's say you found a place where really water is worth extracting. Okay, so you set up a mine there, but that's not an exploration base. A mine is a very concentrated activity on extracting the resource, but it's not necessarily a good place to explore the rest of the planet and roam around. In fact, in all the extreme regions of the Earth where you have a desert, like the Antarctic, the Arctic, or other deserts, if you have a mining operation, you set up your mine wherever it needs to be set up, but it's not necessarily where you build a city or a community that you explore from. You know, uh, what you want at this stage is to set up a base that's an exploration base. You want a place from which it's easy to drive away, where you can reach other parts of the moon, where you can, where the base itself is easy to reach at all times. Um, you know, because it's not good to try to land on the moon in the permanently shadowed regions. I mean, you can't see anything. So all you have is LiDAR. That is, you know, not a very redundant way of landing. And the point is, even if it was possible, it's not necessarily desirable. And so to me, what we should do is focus human exploration on setting up a base in a region that's outside the South Polar region, but not necessarily far from it. It can be, in fact, once again, my favorite location is actually near the South Polar region. It's in the Southern Hemisphere, but it's not in the South Polar region. So it doesn't have this huge amount of permanently shadowed regions. It has a few permanently shadowed regions, but small ones. And actually that makes that landing site particularly interesting as well. But the idea here is to separate the role of the robots and humans now, in the sense of the South Pole is still in the robotic scouting phase. The environment is extreme. We don't exactly know where we can extract water. We should send more and more robots there. And to your point earlier, occupy as many strategic locations as possible. That would be the right strategy. And then for humans, have them set up a base at a place that's user friendly, where you can land easily pretty much at all times, where you can roam from, where you can explore not just the South Pole, but other parts of the moon, so that you really have, control, so to speak, of the rest of the lunar territory. I mean, that it would be a good strategy. In Antarctica, for example, the United States has McMurdo Station. McMurdo is a big base. It's not in, I mean, it so happens that it's an interesting place geologically and scientifically. But the main reason why it's set up there is because it's relatively easy to access. It's on the coast of Antarctica. The sea is relatively open year round up to that point. It's accessible easily in terms of flying time from New Zealand. It has a number of logistical attributes that make it ideal as an Antarctic base. But the work that people do in Antarctica is not just focused around McMurdo. Then you have a mobility system, in other words, airplanes, helicopters, snowmobiles, tractors, to roam around the whole continent and to explore the whole continent. So you use the base as a springboard to explore other places. Many people think that a base somehow ties you down to one location, but it's actually quite the contrary. In Antarctica, if you've done field work in Antarctica, you understand the importance of having a base there and how it enables you to access the rest of the continent because you have an infrastructure on site with mobility systems. So
I'm wondering, conceptually, on public media, we have been talking about building a base on the moon and going back to the moon for quite a while now. So I'm just wondering, how concrete is all this already? Who is currently actually truly developing structures for the moon, for habitats? What will those habitats look like? Is this still a conceptual phase we're talking about, or are we slowly or quickly gravitating toward actual infrastructure on space, on the moon?
there are several efforts going on. In terms of designing a base on the moon, there is no concerted and organized effort about that quite yet. There have been, of course, many architectural studies, many conceptual studies, and these continue today. But in terms of implementing a plan on the U.S. side. Nobody is really funded in a big way to move forward with a base
Hmm.
quite yet. Now there are several Artemis partners who are building um, modules or essentially facilities that
Hmm.
could be the embryo of a base. For example, the Italian Space Agency is working on a multi-mission habitat, MMH, I think it's called, which is a pressurized habitat. But the idea is to somehow put it on wheels so that it could be moved. That right there, in my view, it destroys the idea of a base. And I think that it's not a good, I mean, it has a particular vision and perspective and reason for that. But from a global strategy standpoint for Artemis program and all its partners, it's not what we should be doing. We should be picking a good site for a base and building more modules there and setting up shop. Um, the Japanese also are providing a pressurized rover. JAXA, the Japanese Space Agency, is working with Toyota to build a pressurized rover. So that's a big rover in which you can live inside in shirt sleeves, sleep, and then you drive to explore. So a pressurized rover, in my view, is part of the mobility systems that you want to explore the moon beyond your base. But at the same time, there's no base right now that it would explore from. So it's challenging to sort of design a rover that, you know, doesn't really have a safe haven to return to if something were to happen to it. Um, but unfortunately, there's no concerted effort. Now, the Chinese, on the other hand, in possible partnership with the Russians, and we're not sure to what extent the Russians can afford to contribute anything right now, but the Chinese are definitely building or thinking of a base. And at this point, of course, their focus is to land the first Chinese astronauts on the moon safely and return them back to the Earth. But we don't know where the Chinese would want to set up their base. I would be surprised. I mean, there has been some rumors that they're talking about the Amundsen crater at the south pole of the moon, near the South Pole, but that's actually not a good place to set up a base. So I don't believe that they would be going there. Um, they are considering their first landing on the moon near a crater called Tycho. If you look at the moon at night, you'll see in the lower left, if you're in the northern hemisphere, uh, a a very bright crater with rays going all around it. It's the most prominent one. That's Tycho crater. And so they plan to land, we think, inside Tycho crater for their first landing. Um, that's just
Pascal, Pascal, you launch or you're in the process of launching a course called The Moon and its Exploration. If I'm not mistaken, it's a 6-week course
yeah.
is this for everyone and anyone? And what is it good for?
Yes. So I'm a professor of planetary science at
Mhm.
Kepler Space University. That's one of the hats I wear. And every autumn now, every fall, I've been teaching this course called The Moon and Its Exploration. And it's turning into a relatively popular course. Um, what it does is it is designed for people who don't have a lot of time in their lives, might be busy with their startup companies or just busy as engineers in a space company, even going back to the moon,
Mm-hmm.
but who just haven't had the opportunity to have a comprehensive, compact, uh, core body of knowledge about the moon shared with them yet. So, for example, the goal here, and this course was designed with future astronauts in mind, uh, NASA or commercial astronauts who would need a very compact sort of icebreaker course. It's called a primer. In other words, a few um, key elements to start with, and then from then on you can specialize in this or that. But uh, it's designed for astronauts, but also for people with no technical background, because it goes over things like, the first thing we talk about is the moon as the natural satellite of the Earth. So just understanding the orbit of the moon, the motions of the moon around the Earth, our historical thinking about this. Then the second week we go through um, the history of lunar exploration. So we talk about the robotic missions, but also the Apollo program. Uh, then we go into the geology and the origin of the moon, which is one of the big results of the Apollo program. And of course, even though this is not a course for that's targeting geologists, it but it does make geology accessible to many people. It's also interesting for people who have a background in Earth geology and who might not know about lunar geology. So there's a chapter or a week dedicated to the lunar geology of the moon and the origin of the moon. Then we go into special places and features on the moon. So we have a week dedicated to discussing different areas of the moon that are of particular interest, craters, um, impact basins, the South Pole, the North Pole, and features also of interest, caves. So that is covered in the fourth week. Then we go into the current return to the moon. So all the efforts around the world to go back to the moon, the commercial missions, China, the US, other nations like Israel and Japan, who are landing missions on the moon. And then the final chapter, the week 6, is the future of the moon. So where we talk really about what is really science fiction versus what is the likely future of our moon, and our human
As
future on it.
as a human habitat, you mean?
As a human habitat, well, as a place for human activities. I mean, some people envision large cities on the moon with millions of people. Um, I definitely mentioned that as one of the concepts or ideas that I put forth, but it's not necessarily the one that I believe has a real future. But on the other hand, having multiple bases, having machines that can transport you across the moon very quickly, and once you have a base, then you can access any part of the moon, right? And if by then we find a place where we can extract water economically, well, then you set up a mining operation, and you have a road essentially that goes from the base to the mine. But that's, in my view, a separate thing. It's a next step. It's not, you don't want to build a base on guessing where you might extract the water in the future. I mean, right now, that's what we're trying to do in some conversation, and that's crazy.
Sounds like it's your manual for settlers for that sixth
Yeah,
continent.
yeah. I mean, I think this is the course. It's a bit like a briefing. If I have crewmates or friends or people that I would like to go to the moon with, this is some basic knowledge that I think they need to have across the board, and then obviously they should specialize or dig deeper into whatever they're interested in. Some of my past students, for example, were interested in underground construction on the moon, so that you can build a base underground, maybe in a cave, so that you're protected from radiation from space.
Mm-hmm.
Okay, so but in order to really think of this correctly, you really have to have an understanding, first of all, what we know about caves on the moon today. Also, you need to know about what we know about the ground on the moon. How easy is it to excavate it? What is it made of? What types of machines would work? Which ones would not? So all of these things that are part of the background of understanding how you would build an underground base on the moon are essentially approached in the course. Same thing with another student who wants to focus on building a solar power station on the moon. Okay, so there are places where it's good to do that, and other places where it would not be so good. And then you have to consider issues like the dust that is generated by human activity around a solar farm, rocket landings. You know, you want to power a spaceport on the moon. Well, using solar panels is not necessarily a very good idea with rockets landing a lot and dust getting ejected all the time and coating the solar panels. So these are things that you can you can sort of analyze quantitatively if you have some background knowledge about the moon.
I'm wondering, I don't know if this is too far-fetched, but can all this be compared to the early explorers we've seen hundreds of years ago on planet Earth, like Magellan, Columbus, and those guys who started to make the planet accessible for the Europeans? Is this somewhat comparable? Also, considering the hardships those guys and their crew had to go through, is this something like the next chapter in our history as humans?
You know, I think they had it much harder than we do in many
Interesting.
ways. And
Mm.
they also demonstrated bravery that, you know, might be matched today among humans, but we rarely have a chance to exhibit in the same way. I mean, there's always bravery in battle, which unfortunately still exists today. But I'm talking about bravery of launching yourself on a little boat across an ocean when you don't know if the ocean has an end, and where people tell you that at the very far end of the ocean there's a waterfall. Uh, you know, and that's the end of you.
Yeah.
So navigating to other continents before you knew the Earth was round, that is bravery. That is incredible risk taking. That's incredible, uh, sense of adventure. And I think that for those who actually fly, of course, on rocket missions, uh, that is there. It's captured. It is still not safe to launch on a rocket. I mean, it's still a big
But it's a
risk.
calculated risk. It's more a
Yes.
calculated risk than going on that boat and not knowing if there's
Yeah,
that desired El Dorado at the end.
that's right. That's right. There's at least an outcome that is more understandable. And and then of course the other thing is there were things that were accessible by an individual in the past or a very small group of humans. I mean, the Vikings could sail to Iceland with just one or two Drakars boats, very bravely, but it didn't take a huge amount of logistics compared to, a mission to the moon, where, you can't do this alone or with a bunch of friends. You really need to have you know, thousands of people working with you
Mm.
to make that happen. So I think it takes exploration to a different level. The bravery involved is still there, but the unknowns, the challenges are different, and the risk is also different, of course. But in a profound sense, it's still dangerous. Uh, so I see that as still very exciting. Of course, that the age that we're living in, we're not going to the moon as a routine thing yet, let alone Mars, of course. But eventually this will come. But in terms of the moon, let me just wrap up by saying that the place that I've been advocating for us to set up the base is actually a crater called Clavius.
Mhm.
Now, Clavius crater is at 60 degrees south on the moon, so it's pretty near the South Pole already. And the South Pole is at 90 degrees south, right? So it's 30. It's about 900 kilometers from the South Pole, but it's in a place where you have regular day and night on the moon, like 14 days of daylight, 14 days of night, and where it's a very interesting geology place where there are craters that are old, craters that are young, There are caves nearby. Um, and Clavius is where, in the movie 2001: A Space Odyssey, the moon base was set up.
Mm,
And to me,
mm,
this would be an incredible thing that, and I think it would be a appeal to the public to actually see, uh, reality catch up with science fiction.
mm,
In addition
mhm.
to the fact that it would be a very interesting place, of course, to go, uh, and many of the attractive features of Clavius as a site for a base were not known at the time the movie was made or the book was written. It just turns out that it's a really good place to set up a base, and so this makes it particularly interesting, I think, to sort of consider. Um,
Where are we in all of this? Like, how much time do we still need to conceptualize? When are we actually getting ready to settle down?
well, I think that we're now within a generation of this happening. In the years to come, we're going to see, I mean, barring any major change in direction, we're going to see China reach the moon. And China has a very, it's sort of the turtle and the rabbit, or the turtle and the hare fable. China is the turtle, but it's very steady in its progress, and it's very strategic as well in its approach. Of course, it doesn't have a regime change like we do in the U.S. every 4 years. So that, of course, helps with continuity, political continuity of these programs. Um, uh, I'm not suggesting that a regime change every 4 years is a bad thing. I'm just saying, in terms of having continuity in a program, that's actually an advantage to have a program that allows that. And so we will see the Chinese, I think, do several landings and then establish a base. And of course, the US will either be ahead of this game or playing catch up whenever it needs to. So I do see us moving forward with a base pretty quickly as soon as China sort of attempts to achieve permanent presence. My main concern is that we somehow remain fixated with the South Polar region, when in fact that should be a realm of extreme robotic exploration with some potential in the far future for resource extraction, versus what we should be doing now, which is establish a permanent presence for humans, for Americans and their allies, um, on the moon.
What's what's the what's the fastest turnaround time go for an itinerary to go to the moon and back? So because it seems like it's a lot easier to get ourselves into that interplanetary phase by starting with the moon and not going
Yeah,
to Mars first. So
yeah.
how long
You
does
you
it
can.
take?
It takes 3 days to get to the moon right now. 3 days. So
What
you
if we
can
have
leave.
faster rockets?
That doesn't buy you a lot because I mean, okay, you get there in 2 days instead of three,
Hmm.
but it doesn't buy you a lot. You can leave for the moon on a Monday morning. You get there Wednesday evening. You spend Thursday on the moon. Friday morning, you catch a flight back. Sunday night, you're back at home. Monday, you're back at work. So you can go to the moon and back in a week. And that's literally what was done during the Apollo program. I mean, they usually would stay 1, 2, 3 days on the moon. So it was a week to 10 days, a round trip. Now, obviously, if you have a base, then you can spend more time on the moon. Uh, and with better propulsion, what better propulsion will do is take more people. It might shorten the trip a little bit, but you don't really have the benefit of a very efficient propulsion system to go to the moon until you travel to places like Mars, where, all right, better propulsion system will buy you months of time of travel. And that is not just more pleasant, less tedious, but it means that you have to take less food with you, less oxygen. It's a much more efficient way of traveling through space. Yeah.
You mentioned regime, I'm just wondering, where is the current regime in the United States positioned in terms of Moon versus Mars? Is Moon still of interest?
Yes, moon is of interest because we cannot ignore the moon and let China keep going to the moon and then somehow focus on Mars. I mean, Elon would like to focus just on Mars, although he does agree that a base on the moon is what we should be doing. But it's clear that for strategic reasons alone, going to the moon first is sort of the key thing that has to happen. Now, meanwhile, from a strategic standpoint, even outside of you know international competition, from a sort of a engineering logic standpoint, it makes sense at this point to go back to the moon, plan things well on the moon, get some experience before we go to Mars. But we don't have to delay going to Mars that much. I just, you know, I think that going to Mars with people is something that we can see in our lifetime still, and that should really happen.
Now back to AI. Where is an AI in all of this, in the moon, the
Well,
lunar exploration?
AI is obviously it's sort of the fashionable topic, and everybody seems to jump on board and
Mm.
love it or hate it. And meanwhile, what we should realize also is that robotics is making huge progress now. And very soon, and people will disagree on exactly whether it's 10 years from now, 20 years, or 30 years, but historically, it's very soon. It's just around the corner. It's within a generation. We are going to see essentially artificial humans. We will see androids who are, designed to be physically like us, um, and intellectually as smart as we are. Smart not just in terms of computing power, but just in terms of interaction with others, emotional intelligence, period. That's called artificial general intelligence. Artificial general intelligence has not been achieved yet. We're still in a realm where we are now acquiring narrow artificial intelligence in a number of fields. I mean, we can now beat people at chess, anybody at chess. We can now, um, you know, design AI systems that can create images that would take humans a long time to create. We can have artificial intelligence systems that can create music, you know, whether it's as creative, as good, or not as humans. It's almost debatable now because it's actually really good music that can come out of AI, some very bad as well. But the point about all this is that beyond the growing pains of AI, we're going to see something that will emerge here in the next decades, I think in a generation or two, that are essentially artificial humans. And that has, of course, that's going to have, of course, profound societal impact, because nowadays we still think of these things as machines. We still think of them as robots, but we will get to the point, and they will be designed for that, where essentially they will be indistinguishable from other humans. I mean, other than maybe their biological functions, they will be, in terms of our interactions with them, their skills, our reliance on them, their their ability to help us and to serve us. They will be essentially like humans, and of course, we can anticipate the best and the worst. We can anticipate androids with artificial intelligence who will be very friendly companions to us, and others who will be designed for war. But that's a separate, that's an issue, of course. But in terms of having just humans who will now be beings that we will consider essentially our peers, or even like our offspring. We will have a completely different rapport with machines, I think, in about a generation or two with these artificial humans. I mean, think of the fact that nowadays you can already lend your voice and a few pictures of yourself, and AI can create an artificial you online. We will be able to order a replica of ourselves or a replica of a parent that we've lost. If you have a recording of, I don't know, your parent's voice or your grandmother's voice and pictures of what she looked like, AI can, with an Android, can recreate your grandmother. And whether or not it's ethical or not, it's
It's just happening. It's happening.
it's happening. And then, of course, my point here is that we won't think of them as robots anymore. They will be essentially humans, a different version of humans, but they will be humans. And we might relate to them better than we would somebody from a different culture. Because they'll be tailored to be our companions.
I mean, like
my-
I just heard the other day that I think a Chinese company is planning to put a $20,000 humanoid household robot on the market. So this is crazy. I mean, like 20K. This is a small car, and I think once those things become available at these price tags, this is the moment where we are acquainting ourselves with this technology that you're talking about, where we're becoming or extending our sphere as humans, as Homo sapiens, becoming one
yes,
with this technological something that we're creating.
yes, absolutely. And so far, I haven't talked about space and all this, but you can see how this will solve the whole life support system issue. If we can go to Mars with humanoid robots, first of all, we won't think of them as robots. We'll think of them
Mm,
as humans sent to Mars.
mhm,
But they don't need a spacesuit to go for a spacewalk.
mm,
They don't need oxygen or food. They just need power. And we can do that. We can recharge on Mars. So all of a sudden, I think you know Elon Musk, for example, imagines that we should go to Mars because he wants us to be a multi-planet species. Okay, that's not a bad idea in some sense. But the argument that he presents is that that will ensure our survival. Something bad could happen to the Earth. So if we have an Earth 2.0 on Mars, then we're safe. But where the argument is flawed really is that there's no amount of global nuclear war combined with giant asteroid impact combined with global pandemic on Earth that would make Earth less habitable than Mars. Uh,
mm.
Mars is a terrible place right now to live. I mean, you would die within seconds walking onto the surface of Mars. Um, but on the other hand, if you're open to the idea of, superhumans or androids with general intelligence, or even superhumans, so androids that are even more capable physically than humans and intellectually superior as well with artificial superintelligence, then that opens the universe to us. We can, as much as I don't believe in a million humans living on Mars,
Mars.
which
Mm,
what would amount to a massive um, not only life support system but essentially an intensive care unit, which is what a life support system is. I could imagine us having a million robots on Mars. Building.
Well, I think all this only works if we reach that state of human machine interaction that gives us the impression that machines are
Humans.
like we are, like we're, because as long as machines are out there and not identified as humans, you
Yes,
still feel the urge
absolutely,
to set our
absolutely.
boots on the ground.
Yes, absolutely. And my point is that we're going to get over that very quickly. The machines are going to become so good. We will identify with them so much. I mean, already in some sense we do that, right? Because I mean, we're not going to Mars, all of us. Only very few will go. And of course, they're humans, and we sort of have them carry our dreams and aspirations to Mars. But it wouldn't be, in my view, at least not, it won't be in a decade or two. It won't be that a stretch to see ourselves in AI systems going to Mars. Because, like you say, at that point, if we are no longer seeing a line between robot and human, and if we are somehow viewing them as our offspring or just like somebody else going, uh, I mean, already there are science fiction characters that are like this, right? In the TV series Star Trek: The Next Generation, the Data, Data is a robot, and Data doesn't need a spacesuit to go on the spacewalk.
Hmm.
But when Data breaks down, we are emotionally concerned. We treat Data as a full member of the crew. So I think we have this ability to actually assimilate.
I'm wondering. This is a beautiful example. I'm just wondering where that magic happens and why it happens, because anthropomorphizing dead matter is already happening. So if I, for example, for kids, it's pets, for example, or
Yeah,
a used, exaggerating, a used tissue by a loved person who passed away is l- loaded with emotion. And I
yep,
would never want to toss it away anymore because it carries that loaded emotional whatever soul in it. So I'm just wondering what it is that could make us identify on that level with machines. Is it them being so intelligent? I I would rather say I think it's more a storytelling thing. It's
yeah,
more a thing where we engage with machines because we have told ourselves stories where they are playing a role in our lives and are attached emotionally or vice versa. I don't know. Does that make any sense?
oh, totally, totally. I mean, imagine there's a crew of AI astronauts heading to Mars, and you talk to them and you ask them
Yes.
how are things going, and they start telling you, well, things okay. I'm having some trouble getting along with number four, but otherwise things are good. We're having a good time. We're very excited about seeing Mars. We can't wait to be there and show you what it's like. I mean, as soon as you get into that kind of conversation that's intimate and with empathy, you or perceived empathy, you are you've transposed the whole dialogue into a human relation.
Pascal, there is something I would like to offer you, and maybe hear back from you from your academic perspective, and maybe you can use it in whatever form to hear from you if it works already, because there is something I developed for a European Space Agency. So what I did is I actually connected the Hera mission. That's the planetary defense mission,
Yep.
the second half of the DART mission. I connected that spacecraft, the sensor stream, the telemetry stream from the spacecraft to ChatGPT, and
Yep.
I opened an interface for anyone to use and communicate with the spacecraft. So you can try it yourself. And so I'm wondering, I'm really curious. I'd be really curious to hear your take on this, if this already works, because I believe, to me, it makes sense because I developed it together with my team.
Yep.
So if you're interested, go to hera.space
All
and
right.
you can try it out. And You should totally try voice mode because this is where the magic happens. Don't type, use your voice. And I will send you a pro account where you can use voice mode because voice mode currently is just it's behind a pro wall. It's not available for everyone because voice is still very expensive. So we're only giving it away to selected people. But if you're interested and would love to give us some feedback, I'd be happy to share that voice mode with you.
I'd love to do that. I will. I will check out Hera.space for sure and try the voice mode. I think that, you're onto something that is very, that's at the root of a profound change here in our approach to space exploration. So from that perspective, the SpaceX rocketry and all of that, that's just hardware being hardware. But androids and AI, that's not just hardware being hardware. It's hardware becoming intelligent.
Yeah.
And, that is an entirely different ball game. And of course, even SpaceX and Tesla onto that, they have the Optimus robot that they are designing. So Optimus robot or anybody else's robot is not quite there yet. The Chinese company, I think, Uptech, showed how you have robots now that replace their own batteries, which is interesting to show because even though it's relatively obvious to do, you have an android robot approaching a station and swapping out its battery from the back and putting a new battery in. But that right there is immortality.
Absolutely. Mm-hmm.
On an interstellar starship, that's problem solved. And, think of interstellar travel here for a second. We're faced with considerable distances, right? I think, as you probably know, the nearest star to Earth, Proxima Centauri, is a small red star. It's part of a group of 3 stars, but it's a small red star. And Proxima Centauri is 4.26 light years away from us. Okay.
Wasn't it like something like 70,000 years to travel, something, or 80,000?
Yeah, it's depending on your speed, it's tens of thousands of years to get there. Now, people are thinking of multi-generational starships, where you leave the Earth in a starship, your children are born on board, they keep the journey going, although they have, in my view, very boring lives, and then this goes on for generations, and one day you get to the star. But to me, that's not the right way of thinking about it. There are also people who talk about hibernation. Hibernation, I find interesting for things that can help us humans travel within the solar system as a contingency thing. If we have a problem on a journey, it might be a solution to get ourselves in hibernation so that we can survive or wait for a longer rescue. But going to the stars in hibernation is, super risky. It's a whole machinery that has to keep you alive for centuries. It works on paper. It doesn't make practical sense. But on the other hand, I think the way interstellar travel becomes possible, and by the way, within the next few years, we should start identifying among exoplanets, planets around other stars near us, some planets that have oxygen-rich atmospheres, which by definition would mean that they have life on them, because there's no way to have an oxygen-rich atmosphere on any planet unless there's life there. Oxygen is very reactive.
Have we found any such places yet?
No, not yet. Not yet. But we only at the very beginning of being able to analyze the atmospheres of these planets. So far, we've been able to detect the planets, but not quite see them yet.
Indirectly, yeah.
Indirectly. We detect these planets by looking at how the star around which they revolve wobbles a little bit, or loses some of its light because the planet is passing in front of the star, which is incredible already as when you think about it. But we are getting to the point where we will have telescopes, space telescopes, that can actually see the planet itself and therefore make a measurement of the composition of the atmosphere. So we've already measured the composition of some planetary atmospheres of exoplanets, but we haven't found any oxygen-rich one yet. But someday we will find one, and that will become an obvious destination for us to go. I mean, it'll be, talk about adventure now, where you're going on a mission where you know that you will not be running into humans or Earth-like life. Okay. But the way to do this is to have a crew tended by androids, who have no expiration date. If they can self-repair, self-maintain, and recharge, they can last for centuries. And you will be traveling in the form of your DNA, and maybe a record of who you were, or, I mean, that could be let's say I wanted to be on one of these trips. So my DNA would be on board, and some recordings of my thoughts and history would be on board as well. And then I get replicated once I get there. I mean, I don't mean this in a sort of a self-centered way. I'm just saying that you could be quite specific about who goes, who doesn't want to go, how do you send people there, and how do you reconstruct them at the other side. But that's the solution to interstellar travel, in my view, which is android robots tending to a large bank of human DNA. And of course, once we get
tell me, Pascal, what is the end game in all of this? Are we, because I had a beautiful conversation with someone here on the show, and we talked about Earth as a unique and singular place potentially in the whole universe where life may have originated, but while at the same time now developing technologies to move from planet Earth somewhere else, it's like spawning life into the universe. So is this like a moment where we are seeding, or is this a hybris I'm talking about because it's so human centered? Or does this make sense? Is life seed into the universe and the end game is a living universe?
I'm among the people who say that the purpose of all this is unknown. I mean, the big picture purpose is unknown. I can tell you what motivates us. I mean, in some sense, we're curious. We're curious creatures. We want to know what's out there. And part of wanting to know what's out there goes to the heart of trying to figure out what we mean, how special we are, how common we are. It's about the perspective of ourselves in the universe. Are we unique? Or are there similar forms, even though not identical? What would another intelligent and advanced civilization look like? I mean, those are things that are theoretical right now, but there's an answer to that, which is to reach those places, either ourselves physically, biologically, which is very difficult, or through machines that we create. And then there's, of course, other breakthroughs like, traveling through a wormhole to cut the travel time altogether. But I mean, that's even farther out in the sense that relies on physics and wormholes that we haven't quite mapped out yet, and physics that we haven't necessarily finalized. Not to mention the hardware, the engineering of traveling through a wormhole. But interstellar travel that lasts centuries, I mean, that's something we can do, and it's not necessarily very expensive. If you're sending androids, I mean, by the time we're talking about these androids that we're talking about, they'll be all over the place on Earth. So, 2 or 3 more androids, and you don't need that many on a journey to another star. You could have just 3, maybe 5 androids, for some redundancy, be the crew, and they would carry the DNA of 1 million people, or even more, 1 billion, where it wants to go. And, keeping that preserved and radiation shielded is a lot easier than keeping people
Because
alive.
I guess one of the costliest things ever is to get humans into or off the planet, because we need to put in place all those vital
Yeah,
technologies to keep our. So this is where the money is at. So if we can remove that from the
yeah,
calculation, things get really less expensive.
absolutely, absolutely. Less expensive, and then it's a much more robust solution because it is credibly something that can work over centuries. You're not going to have your offspring rebel against the fact that they were taken on an interstellar travel or journey against their will or without being consulted. Um, you know, so I have all of a sudden hope with the emergence of AI and the advances in robotics. I have new hope for interstellar travel, and I think I mean, just to give you a sense of the distance of the nearest star, we say 4.26 light years. I think I might have mentioned this before, maybe not on your show, but if the sun were the size of a grapefruit, and you put the grapefruit in San Francisco at the beginning of the Golden Gate Bridge, um, Pluto is a tiny little pinhead at the distance of the first pillar of the Golden Gate Bridge. The nearest star is not a grapefruit; it's actually a small cherry at that scale. The nearest star, Proxima Centauri, 4.26 light years away, at that scale would be in Chicago. And if you're
Yeah.
in Jackson Hole, Montana today, right? So
Yes.
you'd be somewhere in between.
Wow.
Okay. So it's a huge distance to travel to those stars.
Wow.
And so we have to be clever about it. We
Wow.
we can send our biological cells, but we have to send our cells in a very compact, basic, fundamental form, which is our DNA. And that still defines us in a profound sense. It won't.
Problem is if we're traveling for tens of thousands of years and then upon arrival we're discovering that there's nothing worth of interest, that's okay.
Well,
Yeah.
you would be targeting a star or planet that has oxygen in its atmosphere, so there would be
Mhm.
life there. Whether
Mm.
it's livable for us, that's different. But the robotic crew on board can then make the executive decision of, okay, do we continue on or do we stay here? So we will trust them for that decision because they'll be like us intellectually.
Pascal, in what form, if someone asked you, would you want to travel into space as DNA, like locked up in a bottle, or as a living person as right now?
Well, of course, I would want to travel as a living person right now, but if it's not an option, I mean, I'll be dead in, if I'm lucky, in a few decades.
Mm.
That's it. But if I was to accept the fact that I could still exist in my DNA as me physically, and then intellectually, if my
Mm.
memory could be captured, or my thoughts could be captured in a sort
Mm.
of digital form, and then somehow was put in the care of artificial humans who
Mm.
will withstand centuries of travel to go to other
Mm.
stars. Hey, I'm on board. I mean, if it doesn't work, fine. At least, I mean, there seems to be, at that point, relatively little cost to huge potential. And
Mm.
it's not just, me physically. I mean, I would want to, travel with a few loved ones, maybe even have my dog go along, uh, and the decision, um, the charm of the decision, the attractiveness of the decision is obviously before you leave. I don't see myself even being part of the initial journey. I see myself being prepared as a DNA passenger, uh, up front and then be loaded on board.
Okay, replicated. So let's go for the replication period. So because you would want to have some music to keep you entertained on that new planet, what would it be? What one piece of music would it be?
Well, there's a song that I really like. It's a pop song called "World Hold On."
Mm,
World Hold On. So, I mean,
fantastic.
you asked for one song. That would be
That would be
it.
the one. Great.
If yeah,
And yeah,
one song I would probably tire of it listening to it all the time as well. But having said that, that's a song I really like.
great.
World Hold On, and I think it would be appropriate. World Hold On. There's a lot of waiting.
Fantastic. And Pascal, my last question, why don't you, I challenge you to share another espresso for the mind with me, a shot of inspiration you'd like to share. You shared quite a bit of inspiration already, but maybe you can condense something into like the super duper energizing shot for me, for the audience, whatever you want to talk about.
Yeah, well, I'm just imagining how, you know, um, a future child is born on this world, and they are educated. They they are educated by the 5 robots, the 5 androids that got to them, who left the Earth centuries ago, but who are now on a planet that's hospitable to Earth life, and they're being taught a bit like Socrates or Plato to their disciples, and they explain that you are humans. They sent us out here centuries ago, and this is a planet for you to sort of explore and conquer and multiply on. We were your servants, but also
Hmm.
your friends and your keepers, your nannies, and these kids are going to grow up in a new world that they have no history with, but they will be taught, who they were. If they are a DNA of people who existed, then they'll be taught who each and one of them was in the past, um, and they will learn about what they did, what their backgrounds were, and in some sense, humanity will pick up from there, and the robots will know how to make more of themselves as well in the new world. I mean, they will be, of course, critical to keeping things going and getting things started and keeping things going. But I'm just imagining this moment far in the future, centuries ahead, where all of a sudden you, me, and whoever is on board travel on that DNA mission comes back to life in another incarnation of ourselves, but on another world.
I'm wondering if there is any kind of cultural memory stored on that DNA.
Cultural, probably not, right? I mean, DNA is just our biological memory, but the cultural memory will be part of our education as growing up as kids. Of course,
Mm.
we'll be our own persons, but we will be taught who we were in our previous life. Um, and that will be, you ask for something that'd be a bit unusual. Well, here's a possibility
Fantastic.
to
Pascal
be
Lee, yeah,
new
yeah,
incarnation of somebody who once was.
this is crazy.
And of course, you're your own person, but you're in a different world with a new start.
It's a beautiful symbol that we dearly need also at this very moment in time, where we're transitioning into something and hopefully making it onto the other side. Pascal, thank you so much for taking that time. It was brilliant, and it was a pleasure.
Thank you, Marcus. Always good to talk to you. You are different as well. The way you
Thank
think.
you.
That's very refreshing.
Thank you. Thank you.
That was Dr. Pascal Lee, a man who thinks in centuries, not years. From the dust of the moon to the idea of humans reborn through machines, it's conversations like this that remind me how close we are to truly rewriting our own story. If you enjoyed this episode, share it with someone who still believes exploration is about more than rockets. It's about meaning. You can find all Space Café podcast episodes on Spotify, Apple Podcasts, and Spacewatch Global. And as always, keep looking up. And as always, if you have something to share, want to share something, suggest a guest, please write into us at podcast@spacewatch.global. Because the future might be watching us. This is one of the reasons why we recommend looking up all the time. Well, maybe not while driving. Have a good one. Bye-bye.